All right, so it's time to pick up where I left off. My phone died. Sorry about that. So we have, let's see. Text messages. Go away. I'm doing math. Okay. So basically I started off by telling you about the index. So here in this first example on the back side of our 6.5 day 2 notes, we have both parts here to the second root. Okay, so because those two are the same, that means that their index is 2. The word radicand relates to the number that's under the square root, and because there's a 6 under the square root for both parts, the radicand is 6. Sometimes there's more than one index, sometimes there's more than one radicand. So that was actually the first example. So I'm going to have us take a look here at the second example, and what we're going to be doing is we're going to be adding and subtracting our radicals. All right, so I'm going to tilt this a little bit more so you can see the whole problem. All right, so I've got 12 root 5 and negative 2 root 5. Of course, I have these ones also, but because these ones have a 7 under the square root, can you see that? There we go. I'll hold it right here. Since we have 7s under the square root for both of those two are going to go together, and then these two are going to go together. These are like terms. They have the same number under the square root. So when I'm adding, I've got a 2 and then a minus 2, and since they're both under the square root and they both have a 5, I can do 12 root 5, because that's this whole term, and then minus 2 root 5, because that's this whole term, minus 2 root 5, and because 12 minus 2 is 10, I can write 10 root 5, and then I can do the ones that I've circled up here. So I have 6 root 7, and I have 8 root 7, so I can write plus 6 root 7 plus 8 root 7. 6 and 8 gives me 14, so I can put plus 14. And then since these are both 7s under the square root, since the base is the same, it stays the same. I'm hoping that you guys kind of got how I got there, but our ultimate goal here is to just check to make sure that the root is the same. So for this problem, it was the second root. For each of these, we're going to get to ones where some of them are 2s and some of them are 3s. Sometimes you might see 4s. Oh, where did my dog go? There he is. Okay, he's all right. So just be looking to see what the numbers look like that are sitting on that little ledge of the square root. Okay, so not only did we solve this problem, but now we have to state what the index is and what the radicands are. So index would be the little number that sits on the ledge. Since they're both 2, all I have to write is 2 for my index, and over here I wrote index radicand, so my index is 2, and my radicand, I have 2 spots for that because I have 2 different numbers. I have a 5 and I have a 7, so I can write radicand is 5 and the radicand is also 7. I have 2 of them. Okay, we're going to move on to number 3. 3 is not too bad. So I circled the third root of 4 and then minus 8 third root of 4 because they both have the same base. They have the square root of 4 underneath, well, they have a number 4 under the square root. So if I have 8 root 4 minus, oh my gosh, why did I write 8? If I have the third root of 4, there's one of those, minus 8 third root 4. 1 take away 8 gives me a negative 7. Negative 7 third root of 4. And then I also have this up here. I have the 5 root 4. So I'm just going to write plus 5 root 4. All right, so could I have totally added all 3 of those together at the same time? Sure. It's just whatever works best for you. So now that I know that these are the same, my base is going to stay the same, And, oh, we can't see because that darn, there we go. I think we can see. Yeah, we're good. Okay. And then I have a -7 plus 5, which gives me -2. There is our final answer. And then, let's see, what was I going to say? Oh, wait, no. That's not our final answer. Just kidding. And this is why you always have to check your work. So this one is 7 to the 3rd root of 4. And this one has the 2. The purpose of our whole thing today is to tell the difference between the 3rd root and the 2nd root. That's the 3rd root sitting out on that ledge, and this one's the 2nd root. So this is our final answer. Ooh, glad we did that, so that gave us something to talk about right there. Okay. So let's move on to number 4. Number 4, we have to reduce the radical first. So if I have 2 root 45 plus 10 root 20, before I can add these two, I've got to make something the same here, okay? So I have 45, and that's going to break up into 5 and 9, and then 9 is going to break up into 3 and 3. 3 and 3 and 5, so I've got 2 root 5 times 3 times 3, and then plus 10 root 20, and the 20 breaks up into, let's do 5 and 4. You could have done 2 and 10. 5 and 4, so there's 5, and then 4 breaks up into 2 and 2. So then I have 5 times 2 times 2. So we're looking for two numbers that are the same, because this is the nth root is a 2 here. It's the invisible 2 that we don't see. So here's two numbers that are the same, 3's. They move outside of the square root. And when we do that, we have to multiply our 3 times 2. And then 3 times 2 gives us 6 root 5 plus, and then I got 2's here. Those two numbers are the same. That's going to cancel out and move to the outside. And then I have to multiply my 2 times 10, which is 20 root 5. And now, because the bases are the same, they both have 5 under the square root. Now I can add my 6 plus 20. 6 plus 20 is 26. Root 5 is my final answer. And it's 5 because when the base is the same, it stays the same. All right. We've got to answer the index. So the index is a 2 because that's the 2nd root. It doesn't specify any other number. So for index, we can write 2. And then for radicand, the number under the square root is 5. So that means our radicand is 5. All right. Moving on to number 5. Remember, you can always rewind or fast forward if I'm going too slow or if I'm going too fast. Okay, so here, again, we're going to reduce the radical first. So 98 is going to break up into 2. Half of 90 is 45. Half of 8 is 4. So we've got 49, 2 and 49. That's some quick mental math there, because I didn't want to type on my calculator right at this moment. And then 2 is done. 49 breaks up into 7 times 7. So now, let me just check. Okay, so that's a 2nd root, that's a 2nd root, and that's a 2nd root. So it's a regular type of problem, because clearly I have a hard time remembering to check for that. So I have 3 outside here. That stays the same. 2 times 7 times 7. So that part is done. Those cancel out and moves to the outside. 7 times 3 is 21. Root 2. Now I have minus 2 root 32 up here. So I have to, got to break up my 32. I'm going to do 2 and 16 because half of 30 is 15 plus 1 is 16. Or you could just use your calculator. 16 breaks up into 4 and 4. You could have also done 2 and 8. And I'm going to stop here. You could reduce it further and do 2 and 2 and then 2 and 2 again. But because I've already got two numbers that are the same, I'm just going to stop right there. So I've got negative 2 outside, and then 2 times 4, and my notes are blowing away. If my notes blow away, does that mean we have to keep doing math? Yeah, probably. All right, so I have 4s. Those are the same, so it's going to bump outside. 4 times negative 2 gives me a negative 8 root 2. Here, I'm going to take a look at my 8 root 18. And 18 breaks up into, you can either do 3 and 6 or 2 and 9. I like 9 because it breaks up nicely into 3 and 3. And then I've got 8, square root, that's a positive 8. 2 times 3 times 3. My 3's are the same, it bumps outside. 3 times 18. 3 times 8 is a positive 24. Again, if you didn't know that, you could use your calculator. And then 2 is left under the square root, so it stays here. So now, what we got to look at is our bases are all the same. So just like with number 3, where we could have just, well, where we thought we could add them all together, here we can. So root 2, root 2, root 2, and they're all the second root. So, oh goodness, 24, it doesn't matter which one you start with, I'm just starting with 24. 24, take away 8, so I've got, well, you could even just type it all into the calculator. 21 minus 8 plus 24. Here I'm doing 24 minus 8, and that gives me, what, 16? 8 times, yeah, no, 18? 16, yeah, 16. So 21 minus 16 gives us what, 5? 16, 17, 18, 19, 20, 21. Yes, 5. Yeah, so I've got 5 square root 2. And there you have it. Our index is 2 because it's that imaginary 2. And we've got a 2 as the radicand. So we can write 2 up here and a 2 right there. Okay, a few more problems left and we will be done. I promise, promise, promise. Oh, just one more. Even better. Okay. I really hope you guys are enjoying the weather outside today because it is nice out. Well, actually, it's Monday, so by the time you get this, it might be Tuesday or Wednesday. But still, I hope it's nice out still. All right, we've got 5 root 27 minus 4 root 48 plus 2 root 8. So what I want to do is I'm going to start by breaking this up. We've got 5 root, let's see, 27 is what, 3 and 9? And then 9 breaks up into 3 and 3. So I've got 3 times 3 times 3. And then here I've got minus 4, square root 48. 48 breaks up into, let's do 12. You could do 12, you could do 4, you could do 2. I think 6 works, 6 times, no. Let's do, yeah, let's just do 12. 12 times 4 is 48. 12 breaks up into 3 and 4. Lots of different things work. And 4 breaks, ooh, I got 2 numbers that are the same. But you know what? I would still break this up just because I'm actually going to go back and double check to see that those all have the same square roots, the same nth power. Let's see, hold on, let me check Miss Bayer's notes here. Don't want to tell you something wrong. Let's scroll down. This is the last problem. Man, my computer's getting hot out here. Okay. Let's see. Nope, it looks like those are all the second root. Okay, sorry, I just wanted to double check because I wanted to make sure that I was showing you the right thing. Okay, so now 4 breaks up into 2 and 2. And 4 breaks up into 2 and 2. Or you could have just stopped with your 4's, take those 4's and bring them outside. You'll get the same thing. Then we have plus 2 root 8. 8 breaks up into 4 and 2. 4 breaks up into 2 and 2. All right, this is super fun. So this one over here, we've got two numbers that are the same. They hop outside. 2 times 5 is 10 root 3. And remember, we only circled two of them because it's the second power. When it doesn't say any number here, it's always the second power. And then our 3 stayed the same. So here we've got a minus 4. I'm just going to kind of carry this down here. 10 root 3 minus 4 root, let's see, there's 4 2's and a 3. 2 times 2 times 2 times 2 times 3. Two things that are the same. 2 goes outside, 2 times 4. And I've got another one, so that one goes outside, and I've got another 2. 2 times 2 is 4, and 4 times 4 is 16, but that's a minus. So I have to do minus 16 root 3, and 3 is left over under the square root. I'm just going to continue to bring this sucker down. 10 root 3 doesn't change in the beginning. And then, let's see, we've got our 8 over here. So that's like plus 2, square root of 2 times 2 times 2. And those two numbers are the same, hops outside the square root. 2 times 2 is 4. That's a plus, so that's plus 4 root 2. Almost done, my friends. Woo! Now, this is the tricky part. So we have to look for bases that are the same. These two first ones have the square root of 3 right here, but this one does not. This one has a 2, so I cannot combine this one with these guys. This one is different. So I can take 10 minus 16, I get negative 6 root 3, and then this part stays the same. Whew. Let's see, how long did it take to do that one? 7 minutes. Not bad. All right. Well, that is the end of section 6.5, day 2. Sorry we had a little break in between. My battery ran out. Ask questions, email Ms. Bear if you have questions. We hope you have a great day.